Okay, so complex numbers. Okay, when you're looking at the square root of a negative number, in the previous unit we talked about the fact that this was no real solution. Okay, and I told you that eventually we would get to the point where we would look at what those possible solutions. Okay, they're still not going to be real solutions. We consider these to be complex numbers. Okay, so this is considered a complex number. Okay, and the set of complex numbers includes the imaginary unit. Okay, it includes the imaginary unit. So when you start talking about complex numbers, you're talking about the fact that it has an imaginary unit. Okay, that imaginary unit is what we call I. Okay, so it's written I. Okay, and it's the number whose square is -1. Okay, it's the number whose square is -1. So I squared is what is equal to -1. Only I squared, not just I, but I squared is -1. Okay, and if I squared is equal to -1, using the power rule that we learned in the last section, okay, if I square root both sides, I would get I is equal to the square root of -1. Okay, so what this does is this allows us to work with negatives underneath an even root by taking out the imaginary unit I. So for instance here on A, the square root of -36. I can rewrite this to say -1 times 36. Okay, and just like anything else, I'm looking at still a square root. Okay, the square root of 36 is 6. And by definition, the square root of -1 is I. So I can take an I out as well as a 6. So I get 6I. Okay, and that's all that's really going to happen. Anytime you see a square root with a negative inside of it, okay, the negative will come out as an I. Okay, so for instance here, the square root of -5. Okay, well the negative comes out as an I, so I would get an I on the outside, okay, on the outside of the radical. Now there is no square root of 5. Okay, so the square root of 5 is just going to stay the square root of 5. Okay, 5 does not simplify at all, so you're just going to leave it like that, I square root of 5. Okay, same sort of thing with C. Now I've got a negative outside and a negative inside. The negative outside has nothing to do with the radical negative inside. Okay, if you remember from previous units, we never multiply anything into a radical. So the negative that's out front is just going to stay out front in my answer. Okay, and then that negative is going to come out as an I, but I'm going to break down my 20 first. Okay, 20 becomes 4 times 5, which becomes 2 and 2, so my 2 comes out, so I get a 2, and the negative inside comes out as an I, so the 2 and the I come out, and I'm left with a square root of 5, because there was still a 5 left over. Okay, so -2I square root of 5 is what you're going to have left over. Okay, so simplifying is the exact same thing that it has been. Again, you're just going to use that negative that's underneath is going to come out and become an I. Okay, the negative that's out front here is still out front here. Okay, so let's take a look at the next one. Because the product rule does not necessarily hold true with imaginary numbers. Because what happens here is if I had the square root of -4 times the square root of -9. Well, the power rule says I should multiply those together, but if I do that here, I'm going to get the square root of 36. Okay? So now I'm going to end up with a positive number and ignoring the fact that I started with negatives underneath the radical. You cannot ignore the fact that I had negatives underneath the radical. So what we have to do is put these things into I notation first, which is what we just did. Okay, we just put things in I notation. Okay, so we have to put them in I notation first, and then we can multiply our radicals together since they have the same roots. Okay, so the square root of -4, the negative comes out as an I, and the square root of 4 is 2. Okay, the square root of -9. The square root of 9 is 3, and the square root of the negative is I. Okay, so then you just multiply these things together. 2 times 3 makes 6. I times I is I squared. Okay, so 2I times 3I makes 6I squared. Okay, well, we talked about the fact already that I squared is equal to -1 by definition. So I can replace my I squared with a -1. Okay, and I get 6 times -1, which is just -6. Okay, so now, same sort of thing with B. Convert it to I notation first. The negative comes out as an I in front. There is no square root of 3, so we just leave it square root of 3. Okay, different here. The reason why I pulled the number out is because the square root of 4 is 2. Okay, but I don't have a square root of 3. That's some decimal, so I leave the 3 inside. Okay, same thing here. The only thing that can come out is the I. There is no square root of 5, at least not a whole number, so we're going to leave it in. And then multiply these two things together. I times I is I squared. Okay, outsides together and insides together. 3 times 5 makes 15. Okay, so I squared times 15. But again, in this unit, anytime you see an I squared, you need to convert that to a negative 1. Okay, and negative 1 times square root of 15, of course, is just negative square root of 15. If you leave the 1 out front, that's fine. It's just not really proper, but either way, you won't lose points. Okay, same sort of thing with C. Lots of ways you could go about doing C. You do have to take the I out first. So you can either break the 8 down and simplify it as much as possible and then multiply. So you can do 4 and 2, 2 and 2. I'm looking for to square root, so I need groups of 2, so I'd get 2 square root of 2. Here I can only take out an I, so I get I square root of 2. And then I multiply those together, so I would get 2I square root of 2 times 2, which is 4. Okay, but the square root of 4 is just 2. So that's 2I times 2, which just becomes 4I. Okay, square root of 4 is 2. So then 2I times 2 becomes 4I. Okay, other way that you could have done it is to just pull this is just a second option. I can pull just the I out and then multiply, so I'd get I square root of 16, and the square root of 16 is 4, so I would get 4I. Okay, either way works. It's totally up to you on how you want to go about doing it. Same thing with D. Okay, as long as you change it to I notation first, that's all that really matters. If you break it down first, which is what most people do, okay, 25 breaks into 5 and 5. So I would get 5 and I, because of the negative under the radical. Square root, I still have a 5 left over, so that'll stay in the radical. On bottom I have a square root of 5. Okay, now since there's not a single plus or minus sign anywhere to be found, and that's super important, there's no plus or minus sign, then the square root of 5 and the square root of 5 becomes 1, so they just go away. So it's just 5I. Okay, but you have to be careful. If there's a plus sign between those two things, then you can't just cancel that stuff, and we'll see some of that in a little bit. Okay, so now complex numbers. Okay, complex numbers can be written in the form can be written in the form A plus BI. Okay, now that does matter. You do have to put the real number first and the imaginary number second. Okay, where A and B are real numbers. Okay, it's not really that big of a deal. You just have your non-imaginary part and your imaginary part. So anything with the I is written second, anything without the I is written first. Okay, the sum or difference, the definition itself is kind of confusing, but I'll kind of walk you through it just to kind of get you used to reading these kind of definitions as you move into college algebra and things like that. You'll be expected to be to understand these kind of definitions, so just trying to get you used to the language. So if I have A plus BI and C plus DI, and they are complex numbers. Okay, so if they are complex numbers. So if A plus BI and C plus DR are complex numbers, okay, then their sum is okay, so if I have A plus BI, which is the first complex number, plus C plus DI, which is the second complex number, okay, then it's going to be the real parts added together plus the imaginary parts added together. Okay, so that's all they're talking about. You're just going to add the real parts together and the imaginary parts together. Essentially, all you're really doing is combining like terms. Now, they don't call it combining like terms because of the fact that I isn't really a variable. Okay, I is actually a value, so we don't really call it combining like terms because we're adding complex numbers. And this is all one unit, and this is all one unit. But Realistically, that's all that's really happening. You're just combining like terms. You'll add the numbers together, you'll add the i's together, and you'll write it in that format. Okay, the difference kind of looks the same. So when you look at the difference of these things, it's a plus bi minus c plus di. Okay, so if I have two complex numbers that I'm subtracting, okay, well that negative is just going to distribute there. So I would get a plus bi minus c minus di. Okay, which just means that when you put that all together, you're going to get a minus c and b minus di. Okay, again, fancy way of saying that you're just going to have to distribute that negative and then combine like terms. Okay, so definition's way worse than the actual application because this stuff actually should be pretty simple. Okay, add or subtract the complex number and write it in a plus bi form. So we do have to put real number plus imaginary number form. Okay, so you just add your real numbers first. 2 and negative 3 makes negative 1. And then you add your imaginary part, so 3i plus 2i just makes 5i. And that's all you're really doing. You're just combining your like terms. That's really it. Okay, same sort of thing here, only I've got that actually, one thing I do want to point out, that I knew that I was adding because of that plus sign in the middle. Okay, if the parentheses are touching each other, that means I should be multiplying. But if there's a plus or a minus sign, okay, next to the parenthesis, then that means I should be adding or subtracting. Okay, in Unit 7, I had a lot of people that were trying to FOIL these big things out, and they don't need to. If there's a plus sign between those things, that means that I should be adding or subtracting. So that's super important. It's going to save you a lot of time and effort multiplying out things that you don't really need to multiply. Okay, so here it's 5i minus 1 minus I. So you're just going to distribute that negative. So I get 5i minus 1 and plus I. So those just change signs. Okay, and it didn't magically become multiplication. This was subtraction. So now I'm just combining like terms. Okay, so I've got a negative 1 up front, and 5i plus I makes 6i. Okay, again, order matters. Real number up front, imaginary part second. And that's all you're really looking to do. So same sort of thing here. Distribute that negative. Negative 3 minus 7i. Negative negative makes plus 6. Do not change that to multiplication. It's addition. There's a negative sign between them, so I should be subtracting a negative, which just means to add. So then negative 3 plus 6 just makes 3 minus 7i. Okay, so that's it for that part. Now, multiplying complex numbers. Okay, you multiply them just like it was an x. Okay, so negative 7i times 3i becomes negative 21i squared. Remember, when I multiply variables, I add their exponents. Okay, so negative 21i squared. And the only difference here is that I squared we know is a negative 1. So we're going to replace all of our I squareds with negative 1s. Okay, which means negative 21 times negative 1, which makes positive 21. Now do keep in mind this means negative 21 times I squared. So when I put the negative 1 in there, it's going to be multiplication. Okay, so same sort of thing here. To multiply this out, I would have to distribute. So 3i times 2 makes 6i. 3i times negative I makes negative 3i squared. Okay, replace your I squared with a negative 1, so 6i minus 3 times negative 1. So that gives me negative 3 times negative 1 makes positive 3. Okay, so I get positive 3, positive 6i. And I just switched the order there so that I had my real number up front and my imaginary number listed second. Okay, binomial times binomial. Okay, there's a minus sign in both sets of parentheses, or a minus and a plus. Okay, that means I need to FOIL. So first, 2 times 4 is 8. Outside, 2 times I is 2i. Inside, negative 5i times 4 is negative 20i. And last, negative 5i times I makes negative 5i squared. Okay, combine your like terms, replace all of your I squared. So 2i minus 20i makes negative 18i. And the I squared becomes a negative 1. Well, that makes negative 5 times negative 1, which makes positive 5. Okay, and then my like terms there, 8 plus 5 makes 13. So 13 minus 18i. Okay, same sort of thing here. Now, a lot of people are still squaring the outside terms. It is very rarely that you're actually allowed to do that. What you should be doing instead is foiling. Every time you see a set of parentheses with a plus or minus in it with a square outside, you need to foil. Okay, so 2 minus I times 2 minus I. That's what that thing says. So 2 times 2 makes 4. 2 times negative I makes negative 2I. Negative I times 2 makes negative 2I. And negative I times negative I makes positive I squared. Okay, combine your like terms, convert your I squareds to negative 1. So we get 4, negative 2 and negative 2 makes negative 4I. Okay, remember when you're adding, okay, like 2x plus 3x would make 5x. You don't change the exponent or anything. Okay, so plus I squared becomes negative 1. And then 4 plus negative 1 is 3. Same thing on the last one, multiplying. Okay, 7 times 7 is 49. 7 times negative 3i makes negative 21i. Positive 3i times 7 is positive 21i. And 3i times negative 3i makes negative 9i squared. Okay, so negative 21i and positive 21i, those go away. I get 49 minus 9 times negative 1. Okay, negative and negative makes a positive, so 49 plus 9 equals 58. Okay, so this we should have recognized because we did this in the lesson the other day. Remember that if the outsides are the same but the signs are different, those are called conjugates. Okay, well, since they're complex numbers, we call those complex conjugates. Okay, so a plus bi and a minus bi are complex conjugates. Okay, and the great thing about regular complex conjugates, just like regular conjugates, is that when you multiply them, okay, the inside terms are going to cancel every single time. Okay, so if I have a plus bi times a minus bi, I'm going to get the outside term squared, a squared, only this is going to become plus b squared. Okay, whenever we looked at it before, we had, when we didn't have the imaginary unit attached, we had a plus b times a minus b. We got a squared minus b squared. Okay, here it's not going to be minus anymore because bi times negative bi, just like up here, gives me the negative 9i squared. Okay, but since that I squared is going to become a negative 1, it's going to convert this to a positive every time. So instead of a squared minus b squared, we end up with a squared plus b squared when we work with the imaginary number, because that I squared gives me the negative 1. Okay, so this is basically just a shortcut. If you're comfortable with the shortcut, use it. If you're not comfortable with the shortcut, don't even worry about it. You can always FOIL, you get the same thing. The shortcut only saves you a few seconds anyway, so if you're not comfortable when you're supposed to use it or when you're not, just don't use it at all. Just kind of keep working the FOIL method. Okay, so here we want to write this in a plus bi form. Okay, well I can't do that as long as I have an imaginary number on bottom, because they want me to actually split this so I have a real part and an imaginary part. Okay, so in order to do that, we have to multiply by the complex conjugate. Okay, so if I have 1 minus I on the bottom, then I'm going to multiply by 1 plus I. Okay, that would be complex conjugates. And I'm going to do the same thing to the top. Okay, so when I multiply that out, on top we're going to have to FOIL, so 2 times 1 is 2, 2 times I is 2I. I times 1 is I times I is I squared. Okay, we do the same thing to the bottom. Again, here, if you're comfortable using the shortcut, since they're complex conjugates, you can do that. If you're not comfortable with it, just FOIL. And that's what I'm going to do because it seems to throw people off when I use the shortcut. So I'm just going to FOIL it all the way out. So I get 1 times 1 is 1. 1 times I is I. Negative I times 1 is negative I. And negative I times I is negative I squared. Okay, now just reduce. Okay, any of your I squared, same sort of thing. We're basically doing the same thing we did up here, only I've got 2 of them, one in the numerator and one in the denominator. Okay, so the 2 stays the same. 2i plus I makes 3i. And I squared becomes negative 1. Okay, on bottom I've got 1. I minus I, those cancel. And I've got minus and negative 1, changing that I squared to a negative 1. So on top, 2 minus 1 makes 1 plus 3i. And then 1 minus a negative 1, remember minus a negative becomes positive, so I'd get 1 plus 1, which is 2. Okay, and now really to write it in a plus bi form, you would just take that and split it. Okay, it's like adding fractions backwards. Okay, because that 2 applies to the 1 and to the 3i, which means I can take it and just split it apart. So I get 1 over 2 plus 3 over 2i. Okay, so 1 over 2 plus 3 over 2i, and that's where you would stop. Okay, 1 over 2 plus 3 over 2i. So that would be my complex number. So let me say that one more time. From here, all you have to do is take each of the terms of the numerator and split it apart. Notice I didn't split the 3 and the I because those are multiplied. Okay, you just split it wherever you find a plus or minus sign. So 1 over 2 plus 3i over 2. Okay, but 3i over 2, I can write the I out front. You don't have to. You can leave it up top. Those are both the same thing. Okay, so either way you want to write it would work. Okay, same sort of thing with B. Okay, so here your conjugate would just be negative 3i. Okay, top and bottom. Now technically the whole goal is to just get rid of the I, so I could really just multiply the bottom by I, and I'll show that to you in a second, and it's going to end up being the same. But let me show you this. Okay, the conjugate, you just change the sign. Okay, so multiplying the top, I would get negative 21i. On bottom, I would get negative 9i squared. Okay, that I squared becomes negative 1, so I'd get negative 21i over positive 9. Okay, and then from there you're just going to simplify, because both of those are divisible by 3. Okay, so I would get negative 7i over 3. Okay, and here there's no splitting or anything to do because there's just no real part like there was here. Here I had 1 plus 3i. This is just negative 7i, so that's just your answer. Okay, now the other way I was talking about. Let me write option 2 down here. Okay, so I have 7 over 3i. Technically, all I'm trying to do is get rid of the I. Okay, so if there's a single term on bottom, this only works if there's a single term on bottom. Because here this isn't going to work. If I just multiply by I, top and bottom, okay, well I'm going to get 7i on top and 3i squared on bottom. Okay, 7i on top, 3i squared on bottom. Well, that I squared is going to become negative 1. So you just get 7i over negative 3. Okay, which technically would work because negative 7i over 3 is the same thing as 7i over negative 3. Okay, and realistically you just pull the negative out front, and then you don't even have to worry about whether it's on top and bottom because that's all equal to the exact same thing. Okay, so either way is valid here. I just kind of do this because people get used to doing the conjugate, so it's it's repetitive. Okay, but here I can't just multiply I, because if I multiply by just an I, well, 1 times I is going to be I. So all you're going to do is take the I from here and move it over here. So you're just going to keep moving it back and forth. You're never going to get rid of it. So you can only multiply by just an I if there's only one term in the bottom, so there's no addition or subtraction. So that's super important to understand. Okay, so now the power of I. Okay, when we did this in class, we kind of worked this all out. Okay, if I have I to the first power, I to the first power is just I. Okay, and if I have I to the second power, I squared we said was negative 1. Okay, I cubed. Well, I cubed is the same thing as saying I squared times I. Well, I squared is negative 1 times I, which would make negative I. Okay, I to the fourth. I could rewrite I to the fourth to say I squared times I squared, because I squared times I squared is I to the fourth. Well, I to the squared is negative 1. I squared is negative 1, so when you multiply those, you'd end up at positive 1. Okay, so it's just going to keep happening, because every time I have an I squared, I'm going to get a new negative 1. And so now I to the fifth. Well, I could say that's I to the fourth times I. Well, I to the fourth is 1, so 1 times I is just I. I to the sixth, same sort of thing. So I to the sixth would be I to the fifth times I. Well, I to the fifth is I times I, which would be I squared, which would be negative 1. Okay, now hopefully you can kind of see what's going to happen. I to the seventh which would be I to the 6 times I. Well, I to the 6 is negative 1 times I is going to be negative I. Okay, and you can see that we're just starting to rotate through the exact same answers again. I to the 8th would be I to the 4th times I to the 4th, or I to the 7th times I. There's lots of different ways I could write this part out. Okay, but I to the 4th is 1, so I'd get 1 times 1, which is just 1. So what's going to happen is every time I get a pair of I squareds, okay, or every time I get to an I squared, I get to a negative 1. Okay, and then when I get another negative 1, I go back to positive 1. And then we just start rotating through everything all over again. So another pair of 2's, I get back to negative 1 and back to positive 1. Okay, so what's going to happen is we call this thing an I clock. Okay, we call this thing an I clock. So what happens is there's only 4 possible answers. Okay, my 4 possible answers, it's an I clock. So here are my 4 possible answers. I have I have negative 1, I have negative I, and I have positive 1. Okay, I, negative 1, negative I, positive 1. I, negative 1, negative I, positive 1. You do have to know the I clock. We will not give this to you. Okay, and then this is my 1, 2, 3, and 4. Okay, most people call this a 4. I call it a 0. I'll tell you why in just a second, but it doesn't really matter as long as you know what it represents. Okay, so what happens is, okay, if I'm just going to rotate through these same sort of ones, starting with this one, so starting with the top. Okay, so I to the 7th would be 1, 2, 3, 4, 5, 6, 7. Negative I. I to the 7th is negative I, and it is. Okay, so let me show you that again. We're here, we're going to start counting at the top. So start counting at the 12 o'clock spot. So 1, 2, 3, 4, 5, 6, 7. So when I go 7 spots, I end up at negative I, and I to the 7th is negative I. And this will work all the time. Okay? But obviously, when I get to numbers like 46, I do not want to sit here and count around 46 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, for instance, 20. That one's pushing it for me, but I'll show you. I'll count it out first. So let's go 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I to the 20th is 1. Okay? Now, easier way to make this happen, because if I give you something like I to the 746 on the test, and that's very possible, I need to be able to handle that. And I don't know about you, but I don't want to sit and count 746 spots. Okay, although I have seen it on a test, I don't want to see you guys have to do that. The easier way is that every 4th will get me right back to the exact same spot. Okay, so 4 of them is going to just keep bringing me back in a circle, bringing me back in a circle. So we're going to just take all of those repetitions out by dividing them out. So if I divide 4 into 20, it goes 5 times, okay, with a remainder of 0. And the remainder is what matters. Okay, the remainder of 0 is what matters. So 4 goes into 25 times evenly. So what that means is I'm going to make 5 perfect revolutions all the way around, and I'm going to stop right back where I started because it goes in perfectly evenly. Okay? So this is why I call this my 0 spot, because my remainder is 0. Other people call it the 4 spot because it's divisible by 4. Okay? So either way you want to look at it, I call it my 0 spot. They call it the 4 spot. It's this spot right here, your starting position. That's going to be your 0 remainder. Okay, so for instance here, so 4 into 46 goes 11 times with a remainder of 2. The 2 is what matters. Okay, because what it's going to say is that I'm going to go on this clock 11 times around this circle. I don't really care how many times I go around this circle. I'm just repeating all these same answers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We don't care about that. All we care about is where we land. So 11 times I'm right here, okay, and then I've got remainder 2. So 1, 2. Okay, so I to the 46th is negative 1. Okay, and you could count it out because you're going to do 11 revolutions. Okay, you're going to end up here at 44, and then you would go 45, 46. That last 2 is going to take me to the negative 1. Okay, so same sort of thing is going to happen here. Actually, let's do I to the 746. Okay, so 746. So 4 into 746. First of all, you got to be able to divide that out. So it goes in 1, 4 minus 3, 4, 4 into 34 goes 8 times. 32 minus, I get a 2 and a 6. 4 goes into 26 6 times. Okay, 26, so that's going to give me 24. So when I subtract 24, I get a remainder of 2. And again, the remainder of 2 is all that matters, because that means I'm going to do 186 revolutions just to come back and go remainder 2. 1, 2. So I to the 746 is just -1, because that's where my remainder 2 is at. Okay, 1, 2 spot, that's your -1. Okay, so I to the -12, do not go backwards. Negative exponents, drop them to the bottom. It is the same thing. Just because we're working with I values doesn't make it any different. A negative exponent moves it to the bottom of the fraction and becomes positive. And then I just have to find what is I to the 12th power. Okay, well, here we go again. 4 into 12 goes 3 times. Remainder 0. This is the important part. So my 0 spot is right here. That's 1. So you get 1 over 1, or just 1. Okay, and that's really it for complex numbers, and that is actually it for this entire semester. Okay, that's going to be the end of this unit. So, test coming up soon. Good luck.